breaking out. What's going on here? Let me tighten this thing down. Well, I moved the screen back. It should give it a second. It's gonna come. It's on the thing. Okay. That's good. All right, let's get started. It's 3:15. Today, we're going to go over high availability and disaster recovery. So my name is Boulos. Today I have with me Austin. Been with Couchbase for about 4 years. Been in the NoSQL space for almost 9, and the database space for almost equal amount of time. So as we go through, we're going to talk about 4 primary sections in this presentation. First is going to be availability, disaster recovery. We're going to talk about 5.0. So you've probably heard a lot of things, a lot of cool things about 5.0. But this 5.0 is just going to be really encompassed just around DR and HA. And then at the end, we're going to close it out with a quick demo, talk about some technologies and what's out there and how that all meshes in the landscape of databases. So I always like to just get a quick show of hands. How many people today are running Couchbase? All right, on. So we got some good power users. As we go through, I'll try to kind of build a little parallel between the relational world and the distributed architecture, just because we all know probably come from relational, and the mindset does differ, just because we're not one database. Relational world, I've got one master. That's where all my rights are. Backing up is pretty straightforward. We're in a distributed architecture. I have no masters. My data is distributed equally amongst n amount of nodes, so I've got 3 different areas to collect my data, and we'll go through that. Hopefully it'll kind of resonate or make a little sense to you. So let's first start with high availability. For those that are new to Couchbase, this is just a picture of a single node cluster. You'll see it's 3 nodes, and each node has their own services. You got the cluster manager. You'll see that we break out data query and index. That's new in 4.0. We call it multidimensional scale. And with Couchbase, one of the key things that we always talk about is trying to remove the single point of failure. And we do that through availability and replicas. And we'll talk about a couple of those techniques and how to avoid that single point of failure. But that's what's going to give you, in the relational world, the 5 nines, the ability to always be able to serve data, regardless of either hardware going down or networks going down. When we do distribute the data, we have a hash. It's a CRC32 hash. So what that really means is no node is considered a hotspot. So when I look at a 3-node cluster, each node has 1/3 of the data. And as I distribute or grow horizontally, I just divide, or 5-node cluster, each node is 1/5 of the data. And that's what gives me the ability to horizontally scale, and that is linear scale for those that are kind of new to Couchbase. When we achieve availability through replicas, and what that means is when I create a bucket, which is synonymous to a database, I specify how many replicas. Each replica is what dictates how many failures or outages I can have. So let's just say I've got one bucket that is with a replica of 1, and when I go to create data or generate some CRUD operations, I'm going to store an active copy and a replica copy. So that's what you're looking at here. So we've got the concept of active and replica. Based on the CRC32, my data is always going to reside on partition 12, node 1. So when I always request my data, I'm always going to be routed to the same node, same partition. Unless, of course, I scale horizontally, my cluster map, which we don't really talk too much in depth about here, but that'll change, and then my partitions will get shuffled around within the cluster, and then I'll be routed appropriately based on what my CRC map, CRC32 map is telling me. When we replicate, it is from memory to memory. So I have a cluster, node 1, which will replicate to its to another node through memory to memory, so it's super fast. I have also the ability to control durability around when I get acknowledgement from the clients or the client may say, hey, you know, I'm happy with the Couchbase node saying I got it, it's in memory, but maybe I've got some data that I want to receive acknowledgement that both nodes, the active and the replica node, have the data. Or one level further, I can say, you know, I'd like to have an acknowledgement when the data persists down to disk. So I've got 3 different durability settings. That's done at the operation level. All our clients are smart clients, and they have the ability to wait for that acknowledgement to come back to say, okay, I'm happy, the data is safe, let's continue on you know, with additional operations. So today we're in 4.6. In 2.5, so obviously we have Community Edition and Enterprise Edition. In 2.5, we started to build an enterprise-grade features. 2.5 is when Rexo Awareness came in our enterprise, and what that means is, and back to the single point of failure, is I want to remove any single point of failures. I don't want to get in a situation where both my copies, an active and a replica, reside on the same rack. So here you're looking at a 3-rack, 9-node cluster. And if my active and replica both reside on rack 3, if rack 3 goes down, I've effectively created a single point of failure. So if I take that you know, a step further, and when I go to deploy Couchbase, when I add a new node in, I actually specify, hey, I'm deploying Rexo Awareness. This node is going to live on rack 3. So when Couchbase goes to distribute those replicas, it'll say, all right, the active copy is on rack 1. I know not to add the replica copy on, you know, rack 1, so I don't ever get in the situation where both active and replica copies are on the same rack. As you think about the failure, when Couchbase is you know, involved, so I know, you know, for those that are familiar with Couchbase, you'll know that there's vbuckets or partitions or shards that get created and distributed, and that's how we scale. In a failure type scenario, there's obviously gossiping, there's a lot of communication and monitoring that occurs within the cluster. In this situation, in a failure, say node 3 goes down, it's deemed as down, it has active copies that it's responsible for serving. So when clients will go to request the data, say, hey, node 3 is down, we have what we call AutoFailover, can be either enabled or disabled, depending on your preferences, and we'll talk about that, you know, here in a little bit. But in the event AutoFailover kicks in, whether it be initiated manually or automatic, those replicas are going to get promoted, and you can see that they're just flipped. The bits are flipped from 0 to 1, so the data doesn't move per se, but the cluster says, all right, node 3 had these active copies of replicas. It was responsible for this data. Those replicas, which were distributed evenly across my cluster, have now been promoted from a replica state to an active state. Node 3 is now removed from the cluster, and what used to be a 5-node cluster is now a 4-node cluster. The clients are unaware that a failure occurred because AutoFailover kicked in, replicas were promoted, and my data still continues to be served, you know, perfectly fine. So again, 0 downtime, availability is done and maintained through replicas. Go ahead.
You don't mind. What about the replicas that were on 3?
So what will happen is once my replicas are promoted to an active state, the next step is to run a rebalance. And that's done through, you know, my ops guys, or I can script it, but when you run rebalance, it'll actually say, hey, wait a second, I'm actually missing a copy of data because what used to be a replica is now an active copy, so I'm missing a set. When you run rebalance, it'll evaluate the cluster and say, oh, there was a failure. I'm going to either add in that node that previously failed, which had the data, or I'm going to create those replicas for you. It's a good question. So the question was, when a failure does occur, can I automatically set it to rebalance? Can I automatically even script that in? So today, we don't necessarily encourage automatic. We actually want some human involvement, whether it be, hey, you know, somebody pulled the cord or somebody, you know, poured coffee on my server, it went down. I don't want to run a rebalance and start moving data when I don't have to, especially if it was by user error or whatever. So today it's automatic failover. The replicas are promoted, and then from there I'll evaluate that node. Is it truly down? Do I want to add it back in? Was it, you know, a motherboard issue? Was it a hardware issue? Maybe it was a network. So, but you can script it. You can say, and set auto failover to disabled, and say, I'm going to monitor the health of my servers. And if I get a server down response after 10 seconds, I'm going to initiate auto failover. And then I'm going to monitor the status of auto failover. Once that completes, I'm going to run a rebalance, scripted. And then from there, I can either add in a new node or say, hey, I sized my cluster accordingly, and what used to be a 5-node cluster is running effectively with 4. So anytime we're talking failover or failures, I have to plan for a node, at least one going down. So my capacity of the cluster has to be sized accordingly. So if there is a failure, my cluster still maintains a healthy state. Because if 5 nodes is operating at 90% whatever resource, whether it be memory or CPU or disk, when one node goes down, my existing 4 are going to be operating at way over 100, or they're going to be pegged. And now if my disk can't accept writes, and any database is going to fail. So I always have to plan for failure. I never really want to run just 3 nodes, because that only means I can accept one failure, and I hope that the workload of 2 nodes can handle everything I'm running. That makes sense? Any questions? Good.
Simply take the worst failure mode you're willing to tolerate.
Yeah.
And see if you're over 80% or 50% at that point.
Yeah.
If the worst failure you're willing to tolerate is above 100% or above 50%, which is your guideline for capacity
Yeah.
surges,
Absolutely.
then add more nodes.
Yep. Yeah. So I mean, we have some built-in monitoring and some thresholds that you can monitor within the admin UI, but most customers will use CLI or REST endpoints and monitor certain thresholds, whether it be disk at 60% or memory at 80%, whatever the threshold it is. Some alert will get generated. Some group of admins will say, hey, I got a problem. I should be looking at this a little closer. So hopefully you don't get into the situation where, my cluster is totally pegged and my performance is not so good, or I can't accept any operations. Go ahead. Yeah, so that's a good question. So let's just say I deploy a 3-node cluster without Rexo Awareness. I go and say, well, you know what, now I want to be a little more available. I want to be a little more conscious of failure. I want to make sure that I don't get in the single point of failure situation. So most customers, if they had the hardware available, they'll add in a new node and start to set up Rexo Awareness. So they add in one node, Rexo Awareness, it lives on Rec 1. And I kind of cycle through, one at a time. Yeah, and if hardware is not a concern, then I could potentially set up XDCR with a cluster that's Rexo aware. Once I get that all replicated over, I just drop, my Boston cluster that wasn't Rexo aware. Any questions? That answer your question?
Yeah, an observation about failure modes. Don't forget the physical. It needs to be one physical rack or one part of the machine room is a vulnerability, even if it's separate racks.
Yep.
Pipes fall down.
Sure. Yeah, it's a good point. Thank you.
Had it happen.
Yeah. I mean, when Murphy's Law always kicks in, right?
Multi-rack systems with multi-machines and one pipe breaks.
Yeah.
Both.
Yeah, and our, there's a couple different techniques around that. I mean, we're going to talk about XDCR here in a little bit on, when there is a catastrophic failure at the data center level, how do I mitigate that, whether that be through backing up my cluster or through replicating it to another cluster that's another data center. Go ahead. So when the question is, I think I heard it was a little soft. In a multiple availability zone, so each, how does XDCR come in? So when we talk data centers, that's either through one data center in Boston, but it's more by a location, and the AWS is by availability zones. So each data center would be considered in its own availability, east, west, southwest, whatever it may be. And then you'd replicate whether it be to another availability zone or bare metal. So XDCR will replicate between the cloud providers and bare metal and vice versa, if you wanted to have some sort of hybrid type solution. Yeah, we talk about that here in a little while. Go ahead. Yeah, so does the replica stay in memory, or is a replica in memory? Yes, it is in memory. So when I size out the cluster, I will factor in what my data set is. I'll have what we call a working set, and I plan based on how big my data set is and how much I want to keep in memory. Now, I may get in a situation where my data set's too big, and I may not be able to keep everything in memory, but I will have a subset or all of it in memory. Does that make sense? Is a replica in memory? Yeah. Any other questions? All right, very good. So let's, I think here is just kind of illustrating that when the replicas are promoted, the cluster map is updated, the clients are now routed to the new locations of where my partitions were or now reside. All right, let's talk about Delta node recovery. So in 3.0, another enterprise feature was Delta node recovery. And what that means is when a failure occurs or maybe an outage occurs and a node is brought down, whether it be planned or unplanned, a failover is initiated. Now, when you go to add in that node, prior to 3.0, Couchbase said, all right, well, I see you're trying to add this node in. I see that there is a data directory. I don't really know where or what data is missing. So what I'm going to do is I'm just going to blow away that data directory. I'm going to send you the full data set. It's clean. You know that it's going to have a full data set. But the trade-off there is now my recovery time is longer, because depending on how large my data is, that recovery or that rebalance, if you will, could take hours. Where in 3.0, our enterprise offering here is that Couchbase will say, hey, this node, I see it has configuration, or was part of this cluster. It went down for 10 minutes or an hour or however long. I see that you're only missing 10% of the data. So I'm not going to send you the 90% that you have all over again. I'm just going to send you the deltas, hence the Delta node recovery. So when you go to add in that node, you'll actually see an option. Do you want a full recovery? Blow away the full data directory, send me all the data again, which could take X amount of time, or just accept the Delta node recovery and send me the data that I was missing during that that small window when I was out. So less data over the wire, quicker recovery time for Delta node recovery. All right, let's talk disasters. When we talk about disaster and how do we approach that, very much different from the relational world, because with cross data center replication, we call it XDCR, we have the ability to replicate either one way or bidirectionally. So earlier I introduced the bucket concept, which is synonymous to a database. I can replicate at the bucket level. So I don't have to do the entire cluster, because maybe I've got a bucket that's session data that ages out after 10 minutes or 15 minutes. There's no point on sending that to California from my Boston data center when I know when it gets there it's going to live for 7 more minutes, get aged out, and purged. Or similarly, if the data starts in EMA, like Germany, has some data restrictions, says if the data starts in Germany, I don't want to replicate to Boston or California, I'm just not going to include that bucket into my replication stream. So I have the ability to select which bucket I want to replicate, whether it be one of 8 buckets or one of 5 buckets. But that's a decision on what data I want. Also in 4.0, I have the ability to filter. So if I have a bucket, obviously it has multiple types. Maybe that bucket has user data, product catalog data, session data, but I only want to replicate the products that are, HD TVs. I can set up a filter so it'll just replicate a subset of the data from that bucket to another location. And with all this comes, the ability to monitor through REST. We have an admin UI. We got the CLI. Go ahead. Yep. Yeah, so when I do set up XDCR, I specify my source to my destination. Yeah, you can have multiple filters.
I'll show that.
Yep, we're gonna do a demo of that. Good. So the question was, can I have multiple filters on XDCR? The answer is yes. And well, it's just a regex, so I think it has to be kind of finite. I can't do like select star from this bucket where type equals product catalog. I can't put some where clauses just quite yet, but the filtering is kind of just this is the string that I'm looking for, and I want to replicate it over. Yeah. Yes. Yeah, so the question is, I've got global deployment, data center in China and data center somewhere else, but there is the need to replicate some data to either some offshore location or another data center, and they would limit what data gets replicated. That would be through XDCR. Yep. All right, so when I do set up XDCR, I specify source, destination, figure out what bucket I'm replicating, what cluster I'm replicating to. It could go one way, could go bidirectionally. The cool thing with XDCR is that I do have the flexibility, and I also have a very clean monitoring tool. When we go through the admin UI, and I don't know if you guys, for those that are familiar, you can actually see how many mutations are waiting to be sent. And if there was a break between the two data centers, let's say there was a network flap, we have conflict checkpoints that say, hey, the network was down for 10 minutes, Boston was transacting, New York was transacting, but they weren't sending data because obviously there's something wrong with the network. Couchbase, when the network is reestablished, we have an internal checkpoint that says, oh, wait a second, the last checkpoint that Boston sent me was 12, and New York sent me 8. It'll send what data was not sent. So there is intelligence between the XDCR to figure out what to send and when. The backup and restore, again, I keep talking about just enterprise type features. In 3.0, we introduced differential and cumulative backup. And what that means is that, I still have to take a full backup, very similar to the relational world. And I start with a full backup on Sunday. And then from that point on, I say, okay, I'm going to use differential backup. So Monday's backup is just going to contain data from Sunday to Monday. And Tuesday is just going to contain from Tuesday to Wednesday. And those files are small, so I can replay them pretty quick. I can restore relatively quick. Where cumulative is just that I have the full backup. Mondays, just has Monday, and Wednesday has Monday, Tuesday, Wednesday. And those files get a little bigger. So the restore is easier because I only have one file to actually replay, but it's a little bigger. The replay time takes a little longer. So each has a little trade-off, but if availability is a major concern, and oftentimes it is, we don't want to be necessarily, mucking around with files and replaying files and trying to back up from restore. Our recommendation is to always just use XDCR, have multiple clusters up, whether it be for, one way or bidirectionally, but know that, I'm never going to have any downtime because XDCR is running in the background and capturing all my changes between the data centers. Any questions? We good? All right. So let's talk about what's new in 5.0. So you probably heard a lot of cool things with 5.0. I think every release, I think I say, oh, this release is the best one so far. And I think 5.0, I could say that is the case too. I mean, you've heard about the index replicas. You've heard about our RBAC, role-based access and control. You've heard about our cool user interface. There's so many cool things in 5.0 that truly are separating us from our competition. But this features are designed or geared towards DR and HA. So back to the XDCR, there's conflict resolution. All right, oh my gosh, where did the time go? There's XDCR and there's conflict resolution. In today's, the default is every document has metadata. And there's a revision ID metadata tag. And as I change my document between the two data centers, say it's bidirectionally, I'm incrementing that revision ID. And when there's a collision between the one document, Couchbase say, I'm just going to grab the highest revision ID. Maybe not the best type of approach. So what we did was we came up with a more granular type of conflict resolution, and we called last right wins. We use our NTP, so we synchronize the servers on a clock, and then we have a concatenation of this metadata tag. We store it in CAS, so it's called check and set or compare and save. But in the end, that's what we're using to figure out who the survivor or victim is between conflicts. Another cool little feature is I've got two data centers bidirectionally. If I have a failure, let's say catastrophic type scenario, my SDKs will say, hey, I'm writing to Boston. Boston's down. The SDKs will automatically route you to the other data center. So it's smart enough to say, hey, there's a failure. I know where the other data center is. That's where my client requests are going to go. And then the fast failover. So we talked about auto failover. The 30 seconds is the default in today 4.x. So node 3 goes down in that earlier slide. After 30 seconds, auto failover will kick in when it's enabled. Or if I disable auto failover, I can monitor that and decrease that 30-second window to whatever threshold you feel comfortable with. In 5.0, we actually minimize that 30 seconds to be between 5 and 10. So if it's set to auto failover enabled, that 30-second window is now 5 or 10. So it's pretty cool from a data standpoint. So data is always being able to serve to our customers. Again, just kind of high level, fast failover. We do it, we achieve it through monitoring. We built in some additional monitoring at the node level, at the service monitor level, and we have some additional analyzers to figure out. So what I don't want to happen is failover to get initiated falsely, and then my data's starting to move around when I don't need it to be, right? Because that would be a false positive. Go ahead. Yeah, so the question is when there is a failure, so let's just say a 5-node cluster, node 3 goes down, auto failover kicks in, promotes replicas to active, so now I got a 4-node cluster. I have to either run a rebalance to say, okay, my replicas are all set, and then I can accept a failure. But I can't, even in 5.0, I can't accept back-to-back failures without running rebalance. No, not without a rebalance in between. Yep, I need replicas because when we have a failover, whether it be manual or auto, replicas are promoted. So now I'm actually missing a copy somewhere because replicas went to active, and some node doesn't have the needed partitions. Go ahead.
Can the brain split here?
No, we don't ever have the split brain type scenarios. So, and if there is, then we have, so when you go to, let's just say, when you say split brain within the data center.
No, between replicas. So you've got network failure, and now you've got two standalone clusters that are mutating away from each other.
No, no, Couchbase knows. Even when that other node, if let's just say they were on two different racks and they don't ever see each other, and then they start to accept nodes. When they join back in, they'll unite again. They'll figure out where the checkpoint, where am I missing data. I know. Well, let's talk about that because that can introduce a lot of different scenarios. So we talked about a failover. All right, here's Austin. Sorry about that, guys.
So we want to make sure you guys get the demo as well. So I'm going to go through a couple of things really quick. Just Austin out there, that's me. I've done a whole bunch of different things over time in the open source community. Former Marine, that kind of thing. But I've got a lot of technology under my belt as far as what I've done. And one of the things that I've done a lot of is talk about HA and DR and implement HA and DR solutions for a lot of different companies. Mostly for Oracle and SQL Server and those sorts of things, which you may be familiar with. I know Couchbase isn't the only database, but there are other things that other people use. And some of the ways they resolve some of the problems are with these things, like on the left side there, the data duplication and host replication and storage mirroring. And data duplication and storage mirroring are two different things because they're used for different purposes, and they all have their own technologies as well. So depending on who you buy, like on the right side where I've got EMC, I've got VMware, I've got DRBD and these other tools that may be out there. HA clustering tools, right? Continually we have either open source or for-pay items that we include in our topologies. Anybody a former Sun customer, like the original Sun, I'm talking about E10Ks and E4500s, and yes, exactly. So these larger systems always required extra stuff on top of the fact that you bought it to keep it running at the optimal level for failure modes and things like that. And so why this is important to me is because I spent a lot of time talking about these technologies and all of the additional ones that we put into place. And so what did we do then? We started to take our servers and virtualize them, our data and virtualize them, our storage and virtualize them, even though we may have had shared storage structures that we invested a lot of time and money and training and those sorts of things in. It doesn't solve every problem. I can't tell you as a former customer of EMC how many times my EMC monolithic arrays had failed during an upgrade or something like this, and that was very disastrous in itself. Causing us to fail over to our other data centers, which was important. We needed to continue to take traffic. Having said that, though, these are some of the components, like on the storage layer, all the different things that you might need to be aware of or implement some solution for, and then of course at the networking layer and your virtual machines and that sort of thing. So that brings us into the cloud. Everybody wants to do the cloud thing because I can put my stuff there, it's as a service, and it just kind of works. Well, it also introduces another problem, which is sort of the sprawl that I had in one place. I've sort of moved to another place because now I can instantiate as many VMs and that sort of thing as I want, which actually makes HA and DR a lot more important than it even used to be when I had these bigger boxes on-prem. Okay, and the reason was because I took a lot of time and effort to make sure that those big boxes on-prem didn't go down. Right, I invested in different things for making sure that that's the case. Now, when I go into the cloud or I use virtual machines or that sort of thing, it changes the paradigm. I still have to have some of these capabilities built in, but oh, yep, sorry about my little build slide there. So all these different capabilities and all these different components that I would typically have to manage are now virtualized into some thing. So as a service, it may not be that big a deal, especially for the developers who just want to get the app to run, okay? But that's not all that really happens behind the scenes, and that's where we come in. So the common approach, as I mentioned, at the application tier, I'm going to scale out some amount of those. Database servers, I'm going to have some of those, and then I'm going to have some storage, kind of the standard cluster approach, being able to scale my data for my application. I may have a virtual IP in here. And then I'm going to connect all that together, and then also I'm going to have like a heartbeat or something for those databases in order to talk to each other so things are aware, or I'm transferring data or doing replication. And then on top of that, I want to have another place to put that same data for the purpose of backup and recovery or some DR scenario that, it could encompass any number of the tools that we've already kind of briefly talked about. And then I would also build up typically another stack somewhere else for complete DR. All right, and so what I get here is I have completely different data centers, which is why I was kind of building out the slide, that operate independently but for the purpose of serving the application. And if I want to do active-active, I'm really just replicating whatever's in the green box into the other box. So another example might be something like this. This is very straightforward, sort of. I mean, I just built a diagram like that, but this example I just pulled off of the web, and this is something that people do today with like VMware. This is not an uncommon thing. So the new approach that we would like to, I gave away all my secrets. Darn it, the animation didn't work right. So basically, we're taking the application tier, letting you scale that out, okay, with something like Couchbase. I got my database servers, and I'm scaling those. And so I'm going to move some things around. Yeah, let me go back here. Yeah. So what are we actually trying to do? So let me go back here. Sorry for that little back and forth. I have a virtual IP, but I'm going to take that out. I have a storage, but I'm going to take that out. And that's where it gets into the new paradigm. I have a data center virtual IP, not really an uncommon thing. That's how my application's going to talk to the world. I have some databases, and in this case, it's a Couchbase cluster. I'm going to go ahead and just have, as I scale my application, I scale my data and my database. But what I'm missing here is that shared storage tier. You can still use it with Couchbase, but it's no longer required. When I think about cloud and what I'm doing there, I now have all these discrete boxes I've built. And when I say boxes, that's the virtual box. It's the thing I'm going to put out there, to then run an application, do the data, that sort of thing. But it may be all encompassing. I always say I want a server of X size with X amount of storage and X amount of networking and memory. That's the unit by which I start to build all these things. And so for something like Couchbase, because we can scale fairly linearly, your application, you continue to add, you scale that fairly linearly. We want to be able to give you that DR capability and scale all of these things to handle as much load as possible. So what do we have built in? Mel's already gone over a bunch of these, but Couchbase replication, right? Being able to replicate the data in one place or to someplace else. It's built into Couchbase. It's not an additional product, and I wanted to point that out because traditionally that's what we do. I mentioned things like Veritas and DRBD and all those things. We're not doing that. That's built in. I can do local within the cluster, and of course remote, with filtering outside the cluster, and we'll take a look at that in just a moment. I know we don't have a whole lot of time here. Conflict resolution, Mel went over that pretty well. I mean, it's really just about making sure that the data I write always has a winner, so it's the best version of data. And then the flexible topologies. I'm not going to go into all the different topologies, but when I show you how XDCR is instantiated, I think you can just let your imagination run wild. I can have, with a single data source, multiple outputs all around the world to different targets, and including different kinds of filters to all those different locations from the same source, and vice versa. And so that kind of gets me to my 4-minute demonstration. All right. Oops, 1 second. Get this off here. Where is my Firefox? Okay. All right, so I've got a Couchbase cluster here. I know this is really kind of big. Let me see if I can. Okay, everybody can see that now. So what I'm looking at here is just a simple cluster. Let me make sure that my session is still active and everything. I'm just making sure we're still good. Okay, so single cluster. I've got multiple services here. The failover type thing, I simply say failover this node. Right now what I'm doing is not a rebalance, but I'm promoting all the replica copies that were on all the other nodes to active. And that one it's not going to disappear. I haven't done a rebalance. I haven't taken it out of service, if you will, but I have failed it out as far as serving data, right? Or query or index or whatever it needs to be. Of course, if I do not pay attention to, like on the indexes, for instance, and this is something that in 5.0 you don't need to think about, but in 4.6, which is what the version is you're looking at here, the indexes, if I did not have copies of my indexes that I used on every node for the purpose of satisfying specific queries, those indices would not be transferred somewhere else. But in 5.0 we have replica indexes just like data. So even though I've taken a node out and I had multiple services, it would not be a problem at all. Now, in this case, we talked about delta recovery. This is the delta recovery button right here. So if I added some data and I just want to bring the guy back in, I simply say delta recovery. I still hit the rebalance button, but because I chose delta specifically, it now just takes the 10% of data or whatever else needs to be done. So you're going to watch it here for a moment. It really shouldn't take a terribly long time, but this is only like 2 CPUs per node or something like that. They're not very powerful for the purposes of this demo, but I also have another cluster. So let me log out and log back in over here. And I will show you my second cluster, and then assuming that I can log out and log back in, of course. Okay, nope, still not doing it. Come on, log out. Close these guys. And while, yeah, okay. That's why I keep the other tab. And it doesn't seem to care, of course. All right. All right. You know what? I've got another, yep. Well, I can still do XDCR back to myself. I need the other IP addresses, so I may be able to pull that up right here, as a matter of fact. Yeah. So let me go ahead. I've actually got it on my phone right here, so I'm going to go ahead and do this. Oops. 4 dot. Yep. 2 1 dot 1 7 dot 1 7. Perfect. Oh no, that 2 should not be in there. Sorry about that. There we go. All right, so this should be my other cluster. Should have different data on it as well. So I'll go to the server nodes. I've got my 3 nodes over here. Buckets. I've just got a default bucket. This one, data buckets. You see I've got a couple different buckets. So I've got the travel sample here. And this is a default sample set that we have. So if you go under settings, you'll see you know, like beer and game sim and travel. Travel is used in our getting started application. So what I'm going to do is just simply instantiate a cluster reference for the alternate cluster. Now, I have multiple nodes over here. I'm not going to use these IP addresses. I'm actually going to type in this guy right here because I want the public ones just to make it easier, kind of a little more relatable. But I'm going to give it a name, cluster B, and the host name over there. I don't need to give it anything else. We're going to get back to topology. If it was 2 nodes, it would be fine. It could be a single node. I really don't care what's over there. What I do care about is there's something to actually connect to. I simply go ahead and give it that. I'm going to give it a password, or you know, for the administrator, and that's the reference, okay, that I've set up. I'm not replicating any data yet because that's the first step, is to get essentially the cluster map and create the connection. Then I go ahead and create the replication. So I'm going to take my travel sample. I'm going to say cluster B, and I've only got the default bucket over there, so I'm just going to say default. And then I'm going to enable filtering in this case. Oops, did not type that right. Airline. Actually, it's all lowercase, I believe. And then I'm going to start replicating that. So in a moment or two, I should see some data start coming over here if I have my, yeah, okay, let's see what data. Okay, so we've got some items that just came in. Take a look at the documents, and of course you can see that those are the airline documents. So as far as filtering the data, it's based off the document ID, you know, and as complex as you want to make the document ID, that's fine. You can put in much more complex regex than what I put in here, but this gives you an example of just simply how to get the data from one cluster to the other. And as soon as you make that connection and it remains alive, it'll just start sending the data. And if I go over one last example to show you kind of what I'm talking about, if I modify, say, airline 10 right here, I think it's the first one that shows up in the list, okay? I'm going to go over here and edit this document, and I'm going to put a description in, because that doesn't exist in here. All right, and now I'm going to go ahead and take a look at what's over here. So, you know, very quickly, just with the change data, it replicates from one to the other, and it's on any of those changes. So as I save mutations of the documents, even if I have multiple replications, like if I went to go in here, and you see I have no remote cluster on cluster B, that's because I didn't set up a replication for cluster B back to A, but I can do that. Yes, there's a question. Say that one more time. The airline underscore 10? Oh, yes. No, just for the attribute. No, not attribute, not within the document at this time. That's a request we get a lot. The first step was to get any filtering in this XDCR at all. Second step is to go a little further. What I typically tell folks today is, if you want to filter on specific elements within the documents or arrays or something like that, you could use Kafka or something like that, even as a loopback feedback process within the same place. But that's about all that we have the time for. I think we've got another session that's about to start. So thank you very much, everyone, and I appreciate you coming.